So I'm going to talk about our exciting project, Astrocast, which is actually a good, we believe it's a good example of a disruption, or potential disruption of existing solution. And basically what it is, it's a constellation of about 64 nanosatellites that are going to be used to provide global machine-to-machine services to global customers at a very low cost. And the disruption is really at the level of the cost. And I'll get back to that later. So what we're trying to solve is basically two simple problems. In the existing machine-to-machine solution terrestrial system that you can find today, they are limited in their coverage. They are regional, most of them. I mean, all of them, actually. And not all of them are optimized for mobility applications. So that's one problem. The other problem is if you want really to have a global coverage, you can do that. You use satellite connectivity, satellite M2M, but it's extremely expensive. And it is not optimized if you want to send a small data. So our solution basically is to put in place a constellation of a 3-unit CubeSat and to sell a data subscription plan that is extremely low cost together with a product which is a miniaturized terminal, this size, about the size of a stamp. And because we are going to use L-band, the antenna itself will be extremely small as well. It's going to be about the same size as the terminal, basically. So this product can be integrated in any type of outdoor equipment and send small data directly to the satellites. And so we believe there is a great opportunity here at the very low end of the M2M market, what we call also the low bit rate application. And we can really target this niche with a system like this because of the low cost. So then the data is sent to the constellation of satellites, then it's sent back to the ground station network, and then sent to the end user through our secured database system. So the applications are, of course, geolocation services, remote monitoring, predictive maintenance, and in the second stage, we would like to develop some specific data analytics services for some key customers. So this is how the satellite looks like. We believe it's one of the most advanced 3-unit platforms available today. It's going to be launched early next year as a demonstration mission supported by the European Space Agency. So we have propulsion on board, and we have a lot of nice technology on this platform. For example, we have a very Swiss technology. It's called a spring-loaded connector. So it means we have a satellite without wires. We have a satellite, the only wires that we have are RF wires. But when we integrate the side panels of the satellite, thanks to this technology, all the subsystems are connected together through the spring-loaded connectors. So it means you save a lot of time during integration, and it makes the integration process a lot easier. So we have several key technology which make this platform a new type of CubeSat platform, and we are looking forward to make it fly. So this is, if there is one slide I want you to understand and remember, is this one. So this is the disruption. So on one side of the graph, you can see the existing offer. So if you have an application where you want to send small data through satellite, let's say 1 kilobyte, it's going to cost you between $1 and $10 today. If you do the same using terrestrial system like the well-known Sigfox or LoRa and a lot of other players, it's going to cost you between 10 to 100 times less, between 1 and 10 cents per kilobyte, depending on the configuration, etc. And the cellular M2M is somewhere in between, depending on where you do it and how you do it. But what we are convinced of is that with a constellation like the one we designed, we can offer a global coverage for a price that is in the same order of magnitude as the terrestrial low-cost players. So this niche that we are targeting, we believe it's between 100 and 200 million devices that can be connected in 2021. And our goal is to reach up to 10% of that niche, which is very ambitious, but we want to set the goal high enough. And we believe that because it's low cost, a lot of new applications will open up. And we have seen that already, and we're going to talk about it actually. Today we have a very high customers' interest. In our letter of interest, we have close to 1 million subscriptions today. And if we could answer that need today with our system, that would generate a revenue of about 20 million on an annual basis, only for the data subscription. So here are some of the customers. I will not go into detail, but it's basically we are solving a very simple problem that is common in a very wide range of industries. And it goes from the automotive industry, heavy machineries, trucks, search and rescue, fishing, transportation of hazardous material, fleet monitoring. The government, of course, are interested by this kind of system, shipping containers, water metering, etc. So we discovered that every week we discover new application, and our goal is not to sell a product to the end user, because each of these applications is different, but we are going to, our customer will be the systems integrator to which we're going to sell the RF module. So what we have achieved today, so we are still very young. We created the company 2 years ago, but we have a great team in place in Europe, and we also have an office in US. We have a very good satellite platform, as I described, and we secured the spectrum, which is what would be, I would describe that as the main obstacle for a startup in the satellite M2M, is to secure the spectrum. So we have access for free to some L-band spectrum to perform our demonstration mission, and this is unique. We have a terminal that is in development. We have already a prototype working. We designed our own data protocol. This is also an important point when you have a satellite in low Earth orbit that has to be connected directly to the objects. The data protocol has to be optimized for this configuration. You cannot use existing protocol if you want to do something efficient. So we have secured 3 million non-dilutive fund from the European Space Agency and the Swiss government, and now we are trying to close our seed round of 3 million as well. And we expect we are going to open a Series A round very soon, and we expect to close this Series A during the demonstration mission that will happen early next year. So we booked already one slot on Falcon 9, and we want a backup satellite to be sure that we can demonstrate this technology, and we will do that on PSLV. So a few words about the people involved. So myself and my CTO, we really come from the nanosatellite engineering side, but we also have expertise from ESA project, and we have also great people involved who have a long expertise in NASA and ESA missions. And our CFO was the former president of Sea Launch, so he has a great expertise from the launch side, a great network as well. And we are working with a fantastic team of advisors. And in the last panel, they talked about the importance of finding the right advisors, and we are very happy to benefit from their great help. We have, for example, Dr. José Achache. He was the former deputy director of the CNES, the French Space Agency. We have an astronaut who is our rock star. And we have people from the ITU, so the spectrum strategy is coming also from that side, as well as other expertise. I'm not going to go in the detail of the partners, but we have a great ecosystem in Switzerland to support such project. And of course, we are working closely with ESA. And a few words about how everything started. It started in 2006 when we decided in Switzerland to develop the first Swiss satellite. It was called SwissCube, and we launched it on PSLV in 2009. And after 7.5 years, it's still operational. So we have demonstrated that a nanosatellite can work. It can be reliable for a relatively long-term mission. And this is very important. And thanks to this mission, we gained a lot of credibility, and we are going to reuse the exact same approach to develop the next generation of satellites. So most of the nanosatellite expertise is coming from this project, which was an academic project. So that's it. I said I was going to be short. And maybe we'll take the question after the panel, I guess.
Great. Thank you.